we will look at writing the equation of a line through two given points. In number 1, the following scatter plot gives the number of visitors that a beach receives given a certain temperature. Graph a linear model through two appropriate points. Write the 2 points that you used. So this question is fairly open-ended, but I'm going to give you some pointers on how to proceed with it. The idea being, in the past we created a scatter plot, but we didn't write an equation for a line representing a linear model for the scatter plot because we didn't know how to write the equation of a line. Well, now, if we're given 2 points, we can write the equation of a line. We need to find the slope and the vertical intercept, the m and the b values. So, to graph a linear model through 2 appropriate points, the idea of appropriate just means that if I use the first 2 points, if I drew a line here through those first 2 points, that line is only going through those 2 points, and it's not even close to any of the other points on the scatter plot. So what you want to look at is you want to draw a line, a model, that is representative of the trend of what's happening. Now, most people could look at this and recognize that it looks like as the temperature goes up, you have more visitors at the beach. So it appears to be an increasing relationship. So as the temperature increases, the number of visitors tends to increase. Now we can also see that if you put a ruler on the scatter plot, that line is not going to cross through every single point. But we can see that if I draw a model right around here on this side, that it's fairly close to the points. It kind of captures the trend of what's happening, that there's an increase in the number of visitors as the temperature goes up. So 2 appropriate points just means you want to capture the trend that's happening. What I would suggest is that because of the scale here, every tick mark is worth 75 visitors. So you can see some of these points, like that very first point, you would really be guessing how many that is. Like it's above 75 and lower than 150, closer to the 75. So you might say there's like 90 or 95 there, but that's really hard to tell. So what I would suggest you do in this case is notice how this point right here, it looks like it's right on the corner of the box. So I would use that point, and then to keep that upward trend, if I take that point and then maybe the point up here, notice how that is right on the corner of the box also. And you can say, well, gee, Marks, what about using that point here and maybe this point? Well, the problem with that is that linear model, notice how if I draw that, all the points would be either on the line or below the line. When you create a linear model, you want some of the points to be above the line and some of the points below the line. You kind of want the points to straddle the line, if that makes sense. So I'll draw a linear model through that point and then the point up here. And you may miss it just a little bit because of the points, but okay. So we can see that line follows the trend. I'm going to circle those 2 points just to remember that those are the 2 points we used. So in part A, write the 2 points that we used. The input 84 gave us an output of 225. So 84, 225. And then the other one was 94, 600. Okay, that was this point up here. Okay, so now all this boils down to at this point is write the equation of the linear model through these 2 points. And that is something that you've done in the past. If I said write the equation of a line through the points 2, 7 and -3, 8, we should all be able to do that at this point. Remember, it comes down to the idea of slope-intercept form, y = mx + b. You need to find m, the slope, and B, the vertical intercept. So that's something that everyone should be able to do using these 2 points. Okay, so go ahead and try to do that, and I'll put the answer up here just for the sake of time. So when I find the slope, I get m equals 37.5 visitors per degree Fahrenheit. So all that's basically saying is every time the temperature increases by 1 degree Fahrenheit, you would expect another 37.5 visitors to show up. The 375 over 10, that middle step, is just saying over the course of 10 degrees increase in temperature, you would expect 375 more people to show up. Okay, so once you have the slope, we know the y equals mx plus b form, and we know what m is. So now take one of your points, xy, and substitute it in. And I'll show the answer what I have for that. I use the second point, 94, 600. Plug in the values for x and y. And notice I get a really small negative number, negative 2,925. Equals the b value. So the equation of our line is v equals 37.5f minus 2,925. Now one thing I'll point out on this is notice how on this one they did a broken line graph on the horizontal axis. That's a little unusual that we see it on the horizontal axis. Usually it's on the vertical. But by the nature of what that axis represents, the temperature, they did a broken line and then started at 80 degrees. Now technically, what this would mean is that if it was 0 degrees, you would expect negative 2,925 people to show up. Now I know there's a lot of weirdos out there that show up to the beach and they do the polar plunge and all that. But what's happening here is basically model breakdown. And that'll happen when you look at values that are well outside of your range. You're skipping from 0 to 80 right here, which is a lot of values outside of your range for the temperature. Your temperature is only ranging from 80 to 96. Compare that to 0 to 80. So trying to predict a value that's well below 80, like 0, that there could be model breakdown happening. Okay, so that's the equation of our line, though. And explain the meaning of our slope. Well, we already mentioned that the number of visitors increases by about 37.5 visitors per each additional degree increase in temperature. You could also say as the temperature increases by 1 degree, you expect 37.5 more visitors at the beach. And then part D, use our model to estimate the number of visitors when the temperature is 87 degrees. Our model we wrote right here. So we can substitute 87 in place of F. And when you do that, you get 337.5. So about 337 visitors. If you round it up to 338 in this class, that's not something that we're going to quibble over. So moving on to the next one. This gives you a region's trend of wages for nurses who've received Masters of Science in Nursing, an MSN degree. So given the years of experience, the average hourly wage. So create a scatter plot of that. You want to think about the years of experience going across the bottom for the input and the hourly wage up the side. Now, before I tell you to pause the video, what I would say is notice that the value starts at $33.50 for the hourly wage and then tends to increase over time. So the lowest you're going to need is $33.50. So that would probably be a good option to do a broken line graph and then start at a value that makes sense. And I'll just tell you what I used to start was at 30. And then I said every tick mark is worth 5. So then I said 40 and so on. So pause the video, create the scatter plot, and then I'll put what I have up here for the answer. Okay, so this is what I have. Now you'll notice that a linear model I have drawn on there, and I should have mentioned that this point, I messed up on, I plotted the same point twice. But it says graph a linear model, so we want to use two appropriate values again. And what I saw on this one, if I start at the vertical intercept right here at 0, 33, 50, and then I use this point right here, which was 16, 61, that gave a pretty decent model. Now there's only 5 points here given, so it might not be easy to come up with a situation where you have the same number of points above as below and so on. So does that capture the trend of what's happening? I believe so. You definitely wouldn't want to use just the first and last points. I'm sorry, the last 2 points, not the first and last. The last 2 points, you don't want to use those, because then you have the line over here, which is well above the points, these 3 points here. So you just want to use 2 points that are keeping in the trend of what's happening and quote unquote close to the points. Okay, so what I used was 0, 33, 50 and 16, 61. So now, this question just now boils down to write the equation of a line or find the slope through these 2 points. And that's something that we should all be able to do. So if you want to pause the video and try that, go ahead and I'll show the answer. And I'll make a note that if you use different points, then your slope might be different. So if you use different points, just be aware of that. But how you describe it and find it is the same process. It's just that your description, instead of saying $1.72 per hour, it may be $1.85 per hour, okay, or something different. Okay, so once you have the slope and explain its meaning, in part C, write an equation relating the hourly wage, W, to the number of years of experience. So we can see that we're increasing by $1.72 per hour, so that's your slope. We need to find the B value. Well, notice on this one, because I use that first point that is the vertical intercept, okay, so when x is 0, you get 3350. Because I use that point, that allows me to use 3350 without doing any work to find B. Now, if you chose to show the work, notice how you have 0 in for x and 3350 in for W, and what happens is you just get 3350 for the B value. But because we specifically use the vertical intercept as one of our 2 points that we graph this line through, we used that as the first point, that was the vertical intercept. Okay, and then in part D, use your equation to predict the hourly wage of a nurse with a MSN degree and 10 years of experience. So that means X is 10. So you're going to substitute 10 in place of X. And you get $50.70 per hour. Now what I do want to point out is people look at that and they say, well, for 10 years of experience, you would expect it to be between 8 and 16. And that is very close to 8 years of experience. Well, you have to remember that this line only goes through, in this case, these 2 points. So the other points are not on our linear model. So any year that we use our formula, our slope-intercept equation, like we did here to substitute in an X value or a W value, it may not match up with exactly what's happening in the table. Another example I'll give you is if you look at 24 years, one way to interpret this is the nurses with 24 years of experience on average got paid $65.60. So that was their average pay. Based on all the data, you would expect them to getting paid more than that. Okay, probably closer to $75. So you can look at that and interpret that as meaning that the nurses with 24 years of experience may be a little underpaid in actuality, because your linear model is predicting a higher value than what it actually was. So you just got to be careful with that, and don't expect your linear model to match up perfectly with the points that are in the table. So that is how you write the equation of a line through 2 points given a scatter plot in context.